In this video, we are going to use implicit differentiation to find an equation of the tangent line to the curve y times sine of 2x equals x times cosine of 2y at the point pi over 2, pi over 4. Okay, so let's begin. First, we want to use implicit differentiation to take the derivative of this curve. So we take the derivative with respect to x of both sides of the equation. So setting that up, it looks like this. Now on the left-hand side, we see that we're taking the derivative with respect to x of y times sine of 2x. So what rule do we think we want to use? Well, we have the product of two things, so we're going to want to use the product rule. Now recall that the product rule tells us the following. If I want to take the derivative, let's say d dx, of the product of two functions, f of x times g of x, the derivative of this product is just f of x times g prime of x plus g of x times f prime of x. So if I'm using the product rule on y times sine of 2x, I get y times d dx of sine of 2x plus sine of 2x times the derivative with respect to x of y. Now notice we have something similar on the right-hand side where we want to take the derivative of x times cosine of 2y. So we're going to want to apply the product rule to the right-hand side as well. So this becomes x times the derivative with respect to x of cosine of 2y plus cosine of 2y times the derivative with respect to x of x. Okay, so now we have some more derivatives to take. So we have y times d dx sine of 2x. So this is y times, well, the derivative of sine is cosine. So this is going to be cosine of 2x times 2. Now what are we really doing here? We're using the chain rule. So the chain rule tells me that if I'm taking, say, the derivative of f of g of x, that equals f prime of g of x times g prime of x. So in our case, f of x is sine of x, and then g of x is 2x. So we have sine of 2x, so the derivative of sine is cosine, and we keep everything inside of sine the same, so that's 2x, and then we have to multiply by the derivative of the inside function, which the derivative of 2x with respect to x is just 2. Now we carry on, so we have plus sine of 2x times the derivative of y with respect to x. So now y is a function of x, and recall that d dx of y, let's say, is really equal to d dy of y times dy dx. Now notice the dy's cancel out, so this is really d dx of y. So what happens here? Well, we can take the derivative of y with respect to y, so that would be 1, and then we multiply by dy dx. Okay, now let's continue on to the right-hand side. So we have x times d dx of cosine of 2y. So now again, we have an application of the chain rule, but we're taking the derivative of something in terms of y with respect to x. So first, let's just take the derivative of cosine of 2y with respect to y. So the derivative of cosine is minus sine. So this becomes minus sine of 2y times the derivative of the inside function, which is 2y. That's just 2. And then we have to multiply by dy dx. So that's this part here. Moving forward, we add cosine of 2y times d dx of x, which is just 1. Okay, now let's simplify our answer a little bit or clear things up. So rewriting this, we have 2y times cosine of 2x plus sine of 2x times dy dx equals negative 2x sine of 2y times dy dx plus cosine of 2y. So now we want to isolate the dy dx, so I'm just going to add 2x sine of 2y to both sides, and I'm going to subtract 2y times cosine 2x from both sides. Doing so, we get the following. So I have sine of 2x times dy dx plus 2x sine of 2y dy dx equals cosine of 2y minus 2y times cosine of 2x. Now I'm going to factor out the dy dx from the left-hand side, and so I get dy dx times sine of 2x plus 2x times sine of 2y, and then the right-hand side stays the same. Now I can divide both sides by sine of 2x plus 2x times sine of 2y to get that dy dx equals cosine of 2y minus 2y times cosine of 2x all over sine of 2x plus 2x times sine of 2y. Now, we've used implicit differentiation to find the derivative of the curve y times sine of 2x equals x times cos of 2y. However, we're not done with the problem yet. What does the derivative tell us? Well, the derivative gives us the slope of the tangent line to the curve. And we want to find an equation of the tangent line to the curve at the point pi over 2, comma pi over 4. So, the first thing we want to do is find what the slope is at that point. We have the derivative, so the next step is to plug in the point. So we want to plug in the point x comma y equals pi over 2, pi over 4. So plugging this in, we get, let's say, dy dx evaluated at this point is going to be cosine of 2 times y, which is pi over 4, minus 2 times y, times cosine of 2x. X is pi over 2. This is all over sine of 2x. So that's 2 times pi over 2 plus 2 times x times sine of 2y. Okay, so let me simplify this a bit. So we have cosine of pi over 2 minus pi over 2 times cosine of pi all over sine of pi plus pi times sine of pi over 2. So we have to evaluate cosine of pi over 2, cosine of pi, sine of pi, and sine of pi over 2. Now we can just draw a quick unit circle here. And we know that here is 0, this is pi over 2, this is pi, and so on. And so the x, y points of the unit circle correspond to the values of cosine and sine. So cosine of pi over 2, so cosine of the point over here, cosine is 0. So this is 0 minus pi over 2, cosine of pi. So cosine of pi is minus 1. Now sine of pi, so now we're at this point again, but we're looking for sine. Sine is 0 plus pi times sine of pi over 2. So here at pi over 2, sine is 1. So we get pi over 2 divided by pi, which is the same as pi over 2 times the reciprocal of pi, which is 1 over pi. We see that the pi's cancel out, and so we are left with 1/2. So what does this tell us? This tells us that the slope of the tangent line to the curve that we started with at the point pi over 2, comma pi over 4 is 1/2. Now to get the equation of this tangent line, we can use point slope form. So if I have a point x naught comma y naught and slope m, point slope form tells me the equation of the curve is y minus y naught equals m times x minus x naught. So in our case, we have y minus our point is pi over 2, comma pi over 4. So we have y minus pi over 4 equals, well, we just calculated the slope. It's 1/2 equals 1/2 times x minus pi over 2. Now we can multiply out the right-hand side, so this becomes y minus pi over 4 equals 1/2 x minus pi over 4. We can add pi over 4 to both sides, so these disappear, and we get y equals 1/2 x. And this here is our final answer. So what does this tell us? This tells us that an equation of the tangent line to the curve that we started with at the given point pi over 2, comma pi over 4 is y equals 1/2 x. If this video was helpful, feel free to like and subscribe.